Hi, everyone. I'm glad to see so many people. Actually, it's much more than I expected, and I believe that it will worth it. So, as it was being said, my topic for today is specifications as a better way of software development. If you're not familiar with specification, that's fine. We will cover it. If you're not familiar with the software development, that's a bit weird, but anyway, we'll cover that. So let me briefly introduce myself from the different perspective. That's true that I'm a software engineer. I have over a decade of experience in a different direction. That is actually surprising for me as well, because I started my career in game development. Then I switched to mobile development. Then I switched to web development, and that's how I leveraged, different experience, different perspective about the software development. And especially, I want to highlight a lot of things which would be useful not only for some particular direction like microservices. It is actually might be useful for everyone. So I try to contribute to open source as much as I can, but it's not that easy to contribute to open source and at the same time have a full-time work, full-time job. So I'm still trying. Considering myself a technical diversity advocate, I encourage people to to learn new technologies, new frameworks, new tools, and experiment more. Because when you're stuck in your existing stack, you might experience some old issues, which is related to some particular problem which was not solved because it was just re-implemented in a different language. So it's very useful to take a different perspective. For example, if you're a Java developer, take a look at Python. I know, but take a look. If you are a C++ developer and, for example, you work with the game development, it doesn't mean that microservices are not important for you. They might be, because at some point you start working with the communication between the game engine and some external service. So a lot of different perspectives, and I encourage you to try the thing which I will be covering soon. And I love developer experience, and that's why I'm here, to improve your developer experience by using more useful and less stressful way of software development. I have to say that it's not about code at all. So sorry for that. I will not give you any code pattern which will solve all of your problems. I will not give you a single library or a single example of the code which will solve all of the issues. And it's also not about AI. I know that it's almost everywhere. Even today we have so many topics about AI. So I will leave it for yourself. You can introduce AI into this topic, but that's not what I'm covering. But no promises. Maybe there will be some AI. I cannot control that, right? So this particular topic will be about my own very personal experience. So I'm not representing some project. I'm not representing some company. It's about my personal experience. And that's, I believe, even more important than presenting some solution-ready tool to use. It's about your mindset. And I want to share the story how the specifications in general changed my developer mindset once and for all time. So what you can expect from this topic? First of all, I will give you some introduction into specifications just to be on the same page. Then I will try to cover modern software development problems which are related to the specifications as well. And we will try to discover how we can use specifications as a solution to all of these problems at the same time. And of course, you might be asking me or yourself, what is the outcome from this presentation? So I will try to give you solid recommendations on how to improve it. So you will get a bullet list of what things you should do to actually start improving the process in general. And to start this interesting topic, we have to understand specifications in the software development and from the software developer perspective. So I believe the best question to start would be, what is a specification? And I want you to please raise your hand if you think or if you understand that what is a specification right now. I expected more, but okay. So that's why we're here, right? I actually wanted to double-check my knowledge before this talk, just to not mess up with the definitions, and I found this very interesting quote on the internet that software engineering is the art of turning specifications into miracles. And by miracles, we mean applications for mobile, applications in web, games, because let's say 30 years ago, everybody would call it a miracle. So now we do it on a daily basis, and AI, I will not cover this. So yeah, actually miracles. But I also checked the Oxford Dictionary, just to be more clear about that, and it turned out that specification is a detailed description of the design and materials used to make something. I want to draw your attention to the word make. It's not about how something works. It's not about how something should communicate. It is about how to make something and what kind of things we should use for that. So basically, specifications can define or describe the process of creating or making things. And in software development, we have a lot of examples. We have types and even subtypes of specifications. For example, a design document. It's a technical list of requirements and expectations about your software. And it could be a specification, right? At the beginning, you have only design document. So we can consider it as a specification because there is described what kind of things we should use, let's say the technical stack, and what kind of things we should provide afterwards. So we can say that it is a clear example of the specifications. But there are more. For designing the software, we use UML diagrams. We have open API specifications to describe your microservices and what kind of endpoints they have, what is the request, what is the response, and a lot of things. Now we have also clouds, also everywhere, and we have infrastructure as code. So basically, to provide something to the cloud, you define the specification, what kind of things you want to use to make your cloud infrastructure. So it is a specification. And the most surprisingly for me was the discovery that actually a method signature in your class or interface also might be a specification. It has arguments or parameters, right? So it's what we use to make something, make the result of the output of some particular function or method in your code. With that being said, let's take a closer look at one of the most well-established specifications in the web development, which is called Open API, previously known as Swagger. And basically, on the right side of this slide, you can see the example of single YAML document, or it might be JSON as well, where you describe all the endpoints, all the data contracts, schemas. So basically, the whole specification of your service. It might be microservice, it might be monolithic service, it doesn't matter. You describe the API. It might be even detached from your code or detached from your infrastructure. So it's just a YAML file. And the main idea behind this specification was to provide all the steps of the software development as the one clear process that can be used by different teams. Let's say that I want to create a microservice. I start with the requirements, so I can collect everything that I should expect and I should get from this microservice. That's the step one. Then we design our API. Basically, we define the specification. And based on these specifications, once we have all the endpoints, all the contracts, all the data schemas, we should understand how it should work. So we can provide configuration based on the specification. Let's say I have authentication based on the bearer token. So now we know that DevOps engineers can go to the cloud and set up everything for this type of authentication, or even on-premise. It doesn't matter. After that, we start the development. And basically, the development is the process when you turn this specification into a miracle, right? So after that, once we're ready with the software, we can actually test it. But the point of this specification that it doesn't matter how your code is structured. It doesn't matter how your code is written, which language, which stack is used. The only thing that matters is how it's supposed to work, how it's structured. So we can write tests even before the service is done, because the specification is already there. And after that, we can publish the specification to some shared resource to share it between team and our organization, and we can deploy the service once we're ready, once we finished with test and everything. So the next question would be, how does it actually help with development? And answer is very, very simple. It doesn't. Because all of these specifications, they just seem like useful thing. But in reality, you just write it manually, and then it's just the starting point for do other manual stuff. Or it might be not that easy. So here we come to the actual problem in the software development processes. We have this pattern, or principle, or approach, it has many names, which is called specification first. And everything what starts with the word and then first actually failed. We have mobile first in web development for the design. It was useful in some times, but it actually failed because we just cannot keep up with this stuff, because we have to do a lot of manual things with this something first approaches. But what about this one? In the best scenario, how it was supposed to be actually, you would start with the writing specification, for example, open API for your service. Then once it is ready, you prepare test cases. Let's say you have a QA engineer, you give specification to them, and they write tests even before the service is done. It is useful because you might write service in Golang, but tests are written in Python or any other example. And you also collect all the business scenarios which will use this microservice. So actually, you can build business scenarios expectation based on the specification already. After that, you start working on the server and client implementation, but the most importantly, at the same time. You don't write backend and then generate the specification to let front-end engineers work on the client side. You start exactly at the same time. So that's how specifications were supposed to work. And once we're done, we run tests. We probably do some minor adjustments. Hopefully, there won't be any, but still. And once we finished with all the iterations, we do the deployment, we publish specifications, and we are ready. And everybody understands how it works, because the specification was there at the beginning. And I have some doubts that this thing sounds like your case. But if it does, I'm really happy for you. But according to the number of hands I saw at the beginning, I don't think so. Anyway, in the more realistic scenario, we have something like this. Basically, all the development starts with some initial meeting for several hours where we describe what kind of service we want, what it would work for, what kind of functionality we should include, what kind of frameworks we will use, and all that stuff. After this meeting, engineers will start working on the design documents. They will start collecting all the requirements and everything on paper, usually. There is some Word document that describes how the service should be implemented. After that, we start server implementation, and as I said, only after this point we can generate specification to let others consume it. And that's how usually client implementation is done. Some backend team finish their service, they publish open API from the existing code, and then mobile application can be developed, and some UI front-end can be developed as well. And hopefully we will write some tests after that, and we claim that we're done. But you already can see all other steps, right? So sometimes we need fixes for front-end or for back-end. We need to update tests, but actually, did we notify the other teams? We should also regenerate the specification, and all that mess just shows to other people that, hey guys, that doesn't work. This specification is a mess. It doesn't help at all. And anyway, we stick to this process more. I noticed that behavior in many companies and many projects, unfortunately, but it's not that bad. Still, the problems we face in these particular situations are the following. First of all, we can have context inconsistencies. You have one specification that was published, let's say, a week ago, then backend team changed something, but front-end team still works with the previous version. So now we have inconsistencies between endpoints, between contracts, between schemas, and all these things. You have to automate this process to make it published or visible for everyone. Then we have higher maintenance cost. Because if you have things to maintain, it basically automatically converts it to additional costs, right? Additional engineers, additional things, additional infrastructure, additional steps in the work. We have blocked engineers, and I believe this is the worst problem. Because if you cannot start working on the whole platform, but you have to wait for the backend, have to wait for some additional fixes, it's the nightmare. It's a horrible situation, and I believe that we should change it. Time to market is worse, because we have just more time to finish stuff. We have broken developer experience, because everything is manual, and everything has to be synced between engineers, between team, and it's a horrible experience from the software developer perspective, for sure. And it's not that easy to make changes to this kind of products. Because if you change something on the backend side, it should be reflected somewhere else, right? In the front end and the mobile app, so you have to keep up with all the changes. And it's not that easy to keep in sync, especially if you have distributed teams and different time zones, or you know how it works. So what is the solution here? And again, solution is quite simple. Just don't write code without the specifications at the beginning. And that should be the end of my presentation, so thank you. But yeah, jokes aside, we actually have a solution. But let's take a look at the industry, right? We do what industry does. And basically, industry dictates different point of view. If you have, I don't know, Django, framework for Python, the most popular framework still, but it's quite old. Anyway, they have REST Swagger community package that generates specification from your code base. So first you write endpoints, you write backend logic, all the implementation, and then you generate specification for your front-end members. Then Flask, also in Python community, same stuff. Community package, generate specification from the code. Fast API, same situation. .NET Core with C#, same situation. We generate specifications always from the code base, which is completely wrong by the definition of the specification. And Azure Functions in Azure Cloud also have this as a core feature. So it's not like community package that was introduced as a part of core functionality. So everybody will believe that it's how it's supposed to be, right? We should use this because it's a core feature. Symfony in the PHP world also have community packages, and I actually checked a lot of examples and a lot of languages, and I never found really popular package that would do it differently. It's always about generating specifications from the code base. So it looks like specification first failed, as I said at the beginning, but code first won. And it might be true, but not everywhere. So actually, we still have an opportunity to change the industry because I believe in the power of community. And community can dictate different point of views, and industry might be changed. And that's how I changed my mindset. It was maybe 6 years ago. I noticed some package which was named GoSwagger, and it was the Golang package which was used to generate the whole code base from the specification. So the proper way, the way how it was supposed to be used. And it's not only about the simple stuff, to generate client SDK, which code is unmaintainable, unreadable, and it's just do the requests against your API. No, you can generate server steps. You can generate tests, functional, integration tests, unit tests, all kind of tests. You can generate all the models and details, and you can provide additional configuration how it should be generated. Should we store it in one directory? Should we store it in subdirectories? How should we name it? So basically, you define by your specification how the code will look like. And that's Really nice experience, because with usage of this package, I saved like 80% of my time spending on the code writing. Because everything was generated automatically, so I have to write the business logic. I don't care about the models, I don't care about the endpoints, how the authentication works, about nothing. So in this particular situation, I was happy, but I was not happy when I realized that it's actually it works only with the second version of OpenAPI, and it's still written in Golang. So if you have a Java or Python project, it's useless. But this is how specifications actually help with the software development. This is the best example of how we should work with all kinds of projects. Microservices, okay. Monolithic service, okay. Communication between services, okay. And there are more packages. For example, from the Swagger team, which created the specification initially, they published something like a code generator. It's named Swagger CodeCan. It was an official package, which is currently kind of deprecated. But we have community fork. Community, again, has the power, which is named OpenAPI generator. It has a wider support of more languages, more frameworks. You can generate code for Python, Java, Golang, Rust, and all kinds of frameworks. And it allows you to extend the functionality by providing your own templates with more complicated stuff. So there is no need to use some predefined solution. You can extend it to your needs. But still, it's written in Java, so if you're not a Java expert, it will take some time to set up all the tooling. And I was also surprised that actually there are more specifications, and not only about OpenAPI. For example, Async API, which still has quite low number of stars on GitHub, and they provide the similar experience to OpenAPI, but for asynchronous communication. For example, I have Kafka, I have RabbitMQ, I have some additional tools like Redis queues and so on, and I want to generate all the code as well. Async API is the way to go. Also supports additional templates, extensions, and they have more tooling by default, so it's even more, let's say, evolved than the OpenAPI community. And there is one more question. Is there something else we can use or we should know about to improve our software development processes? And actually, I checked the open source, and there are thousands of packages. You just need to know what you're looking for. TypeScript, they got you covered. The Golang, exactly. We can find it, and all other languages. I also was kind of impressed, and I contributed to this community, created my own package for working with the specifications in Python, which is OpenAPI free parser. The naming is not perfect, but anyway, it do this stuff. So we have so many packages, and I believe that that's just the beginning. Right now, we can already replace all the boilerplate code with the specifications. But your imagination is the limit. What if we create new type of the specifications to define the metrics, to generate all the code to work with Prometheus, to work with OpenTelemetry, and all other code which is required to integrate with some particular external systems? We can generate storage API specifications. If you have S3 buckets and you want to share it with some microservices, let's keep it as a specification and generate all the code. There won't be any need to write code for new teams who wants to work with the same storage. Search API, Elasticsearch indices, and maybe other search platforms that you use. Just create a specification and generate code from it. Data API, data lakes, shared storages, shared databases, it all can be covered by specifications. And yeah, as I said, you can use AI. If you don't want to write these code generators, use AI to generate this code. You just need to find a structured way of describing things. And there is no need to learn it as a new language, as a new tool, as a new framework. You just need to understand what kind of things you are describing. So what's the impact if you start working with this? I personally believe that the proper specification-first approach can give you better quality assurance, better processes, because you can test things without things. You can get more happy engineers because they write less code and they can do faster development. You get fewer errors, you get less communication overhead, and everything results in the better project structure. Of course, there are some cons, right? It's still language specific. It's more tough to refactor. You have compatibility issues. You have to keep in mind that it's just a specification. It's not about the exact implementation. So keep in mind that it's just template engine, but it can solve so many problems. My personal recommendations would be that to start working with that, you should start with the small project or maybe new microservice. Don't try to cover existing solutions, existing monolithic services. Use open source because it's huge and it's useful. Care about developer experience and try to automate and enforce these things. Because everything what is optional, it's optional, right? You can skip it. So I believe that done it is better than perfect, and this principle helped me a lot of times to manage and reach my goals. So these are resources I mentioned during this talk, and that's all from my side. Thank you. You can scan the QR code to find my contacts. And if you have any questions, I'm ready.
Okay. Thank you so much for that presentation. It was really, really good. I especially loved the false finish when you did like that part, because every time a speaker does a false finish, the two things happened. People on the backstage are like, oh crap, he finished early, we have to figure out this. And then some audience members were like, oh, I'm gonna go away for the next talk. So I love that, you delivered that super well. So we still have time for some questions. A reminder that you can leave your questions on the World Congress application and upvote them. So let's see which the top upvoted one is right now. So what do you think the reason most of the tools generate open API spec from the signatures of the server implementation and not vice versa?
Yeah, I actually asked myself several times this exact question. And I believe that it's just the detachment from the whole process.
Okay.
So when you work with the, let's say, some specific Python framework, you don't care about what will happen to the front-end team, right? You care about Python code. So the only way to make it work to generate specification from your code. And yeah, that's how it works. I believe they just don't think about others, how they will work with the specification.
Okay, let's check. Just a reminder for the people that are leaving, try to keep it a bit low, because then the noise starts messing stuff up. So let's try to make sure we can still hear everything. So the next one, how do you introduce a software specification for a legacy system?
That's a good question. That's a tough question. That's exactly why I give this recommendation that we should try on a small project, because that was my personal experience. We had a huge monolithic legacy system, which had, I don't know, maybe not thousands, hundreds of endpoints, and it was not covered by the specification. So that was a problem. And we spent 6 months trying to figure out what would be the best way. We tried to cover partial parts of the system. We tried to cover some specific endpoints, and we failed. So that was the reason why I created another package, because I tried to enforce that. And I believe that enforcement might be a solution for all monolithic services. So start with the enforcing, I don't know, at least 100 endpoints should be covered. Then at least 200 endpoints should be covered, and so on. So increase the enforcement.
Okay, and we have time for one last question. Let's see the most upvoted one. It's this one. So, do you believe OpenAPI v3 is the best specification language? Opinion on alternatives?
I would say that it doesn't matter. And I don't have any personal preference about OpenAPI or some particular specifications, because I believe if we have some common way of describing things, that would work. Right now we have OpenAPI, Async API, Open Feature. A few hours ago, I saw some company who created specification for role-based access control, and I was impressed because, you know, it touched my heart. So basically, I don't think that some specifications are better than others. We should stick to some community, I don't know, wishes and improve the quality of developer experience.